What NOAA's data is telling us about this hurricane season, NOAA is forecasting between 17 and 25 named storms this season. 6 to 10 of them are expected to become hurricanes. 3 to 5 of those could reach Category 3 or higher. Those are not worst-case numbers. They are the central range, published in May before a single storm had formed, and they describe one of the most active seasons on record if they verify. Here is what is driving that forecast, and what the data actually means for the months ahead. Every year in late May, NOAA releases its Atlantic hurricane season outlook. It is not a storm track forecast. It does not tell you when or where a specific hurricane will hit. What it does is give a probabilistic estimate of total seasonal activity based on the large-scale atmospheric and oceanic conditions that are already locked in place weeks before the peak of the season arrives. Those conditions determine whether the Atlantic will be productive or hostile for hurricane development, and they can be measured months in advance with reasonable accuracy. The two factors that carry the most weight in that forecast right now are sea surface temperatures and wind shear. Start with the water, the main development region, the stretch of tropical Atlantic between roughly 10 and 20 degrees north latitude, where most Atlantic hurricanes are born, is running significantly above its long-term average. In some parts of that corridor, temperatures are more than 1 degree Celsius above normal for this point in the year. That number matters more than it sounds. A warmer ocean does not just fuel individual storms. It extends the window during which the atmosphere over the Atlantic can support rapid intensification, the same process that drove a recent storm from tropical wave to Category 5 in under 5 days. A warm main development region means more storms get a chance to become dangerous before the season ends. Wind shear is the other half of the equation, and right now, it is working in the storm's favor too. Wind shear is the difference in wind speed and direction between the lower and upper atmosphere. High shear tears developing storms apart before they can organize. Low shear leaves them free to build. The current pattern has shear running below average across much of the development region, which means storms that do form will have a cleaner environment to intensify in. Both drivers are pointing in the same direction, and that alignment is the core reason NOAA's numbers are where they are. There is also the broader ocean state to consider. The Atlantic meridional mode, a measure of how much warmer the tropical North Atlantic is compared to the tropical South Atlantic, is in a strongly positive phase. When the northern side runs warmer, it enhances the circulation patterns that feed hurricane development and suppresses the dry air intrusions that would otherwise limit it. Historically, positive Atlantic meridional mode years are associated with significantly above average hurricane seasons. The current reading is one of the strongest in more than a decade. It helps to put the numbers in context, because a range of 17 to 25 named storms can sound abstract. The long-term average for an Atlantic hurricane season is 14 named storms, 7 hurricanes, and 3 major hurricanes. The forecast range sits well above all 3 benchmarks. For comparison, 2024 was one of the most active seasons on record, with 18 named storms and 11 hurricanes. The 2026 outlook is projecting activity at or above that level. The upper end of the forecast range, 25 named storms, would place the season in the company of 2005, the year that produced Katrina, Rita, and Wilma, and exhausted the standard list of storm names before October was out. That comparison deserves a careful note. A high number of named storms does not automatically mean a high number of landfalls or catastrophic impacts. Some of the most active seasons on record produced relatively few major landfalling storms, simply because the tracks stayed out to sea. Season totals measure what the Atlantic produces. They do not tell you where those storms go. A quiet landfall season can follow an extremely active one, and vice versa. What a high seasonal forecast does tell you is that the baseline probability of a dangerous storm reaching a populated coastline is elevated for the entire June through November window. There is one criticism of NOAA's seasonal outlooks that surfaces reliably every year and deserves a direct answer. The claim is that NOAA consistently forecasts above normal seasons, regardless of the actual conditions, either to justify its budget or to avoid the embarrassment of underpredicting a bad year. The record does not support that. In years where the large-scale conditions favor suppressed activity, such as strong El Niño years when increased wind shear over the Atlantic disrupts development, NOAA has issued near normal and below normal outlooks. The 2022 outlook was issued during an El Niño transition and reflected that dampening effect. This year, the conditions are not ambiguous. The data points in one direction, and the forecast follows it. Three things will determine whether this season verifies at the high end of that range or tracks toward the middle. The first is whether sea surface temperatures in the main development region hold through August and September, the peak months of the season. If an unusual pattern of upwelling or increased cloud cover pulls those temperatures down, the fuel supply weakens. The second is the behavior of the African easterly waves, the pulses of disturbed weather rolling off the African coast every few days that seed the majority of Atlantic hurricanes. A productive wave train in August is the engine of a busy season. The third is wind shear. Any shift in the upper atmospheric pattern that brings more shear over the development region would be the single most effective brake on seasonal activity. NOAA updates its outlook in August with the full summer's data in hand. That update will tell us whether the season is tracking toward the forecast or pulling away from it. We will be watching the sea surface temperatures, the wave train, and the shear pattern, and we will tell you the moment any of them shifts.